In this video, I will talk about the factorial design in experiments. This is something that you will absolutely need if you are to write up the design of your experiment for a conference, for an academic paper, or for a client for who you've done an experiment as part of your consulting marketing research. Such words as factorial design may sound very scary, but let me explain it to you so it is super clear. Just as a refresher, an experiment is basically a method of investigation in which you vary the levels of your independent variable, just as shown on the screen, in order for you to measure the effects on the dependent variable. In this video, I'll take a perspective of a random allocation of your participants to experimental conditions, which means there should be no researcher bias from the beginning of the experiment. So I am taking the perspective of true versus quasi-experiment. And just as a refresher, anything which makes sense can be your dependent variable. It could be the knowledge if you are running social interventions or some policy interventions to see what eventuates in better outcomes in individuals or consumers. It could also be attitudes, and it could also be behavior if you're looking at intentions, the actual behavior, health outcomes, or food choices. Let's have a look first at a very simple experiment where we have only two levels of manipulations. And the independent variable I'm using here is mood manipulation. It goes back to the video that I made about what experiment is all about. How do we write out these results to explain other people what is it that we've actually done? There are several rules that tell us how to do that, and they are very simple. First, you need to think about your independent variable as a factor. That's why I am calling this factorial design, and N here stands that there could be multiple factors, multiple independent variables that you may be manipulating in your experiment. But in this one on the screen, I have only one factor, which is mood manipulation. I will show you more complex examples in a few seconds. And the overall description of your experiment would follow this logic. You conducted a to, and then in brackets you have manipulation name for your independent variable, for your factor, the name for the first manipulation versus the name for the second manipulation, factorial, between subjects, experiment. Between subject experiment is basically a description of the overall nature of your experiment, because it could also be within subjects. If you're not sure what between subject experiments is or what a within subject experiment is, please watch a video on this channel. I have a dedicated video for it. But as you might have already guessed, these two here actually stands for the number of levels that you have in your independent variable. You have two. My overall manipulation name, my overall independent variable is called mood. And the name of the first group or of the first intervention or of the first condition is sad mood. So sad mood will be here instead of group 1 name, and group 2 will be happy mood. And versus here actually means that group 1 is compared to group 2. Sad mood will be compared to happy mood to see which one results in different choice of ice cream. This is a very simple example. Let's make it more interesting and let's have more than two groups in our independent variable. And here it is on the screen. Again, I'm assuming that I have random allocation of participants to my conditions. This time within my first factorial or one factorial design, I have 4 levels of variation. I have intervention 1, I have intervention 2, I have intervention 3, and I have a control group that does not see any of these interventions, because I'm trying to see between those 3 ones, which one is more effective, which one is least effective. And the comparison to the control group allow us to see what is going to happen when there is no intervention. How do we write it up? Obviously, we have now 4 groups within our independent variable manipulation. And here I'm taking a perspective of more complex psychological or marketing experiments where I am layering my studies, which means in study 1, I want to examine or establish the effect of only one factor. And then in study 2, I may add something else to see how does this factor interact with something else in influencing the phenomenon that I'm studying. I'll show you a few examples in a second. over here, as you can see, now I have 4. And this number 4 stands for the number of groups that I have. I have 4 of them. My manipulation name is the overall name for this independent variable. And then group 1 is my intervention 1, whatever I call it. And then I say it's versus group 2, whatever it's called, and versus group 3, whatever it's called, and versus group 4, whatever it's called. Sometimes here you would actually say control group if you're using a control group. And again, it is a factorial between subject experiment. Let's make it more interesting now, and let's move into a 2 factorial design experiment. And 2 factorial, as the name suggests, means that there is a second independent variable that we are manipulating. That's why I have this question mark here. And I'm sticking still with the between subject experiment. So now we are going to a more complex design where I have already carried out study 1. And I'm interested in carrying out study 2, where I say, okay, having established the effect of this independent variable, now I would like to see which of these conditions will become stronger or weaker if another variable, another factor is varied. So that means this time I have a 2 factorial design. This is my first factor, and this is my second factor. And the X sign here basically suggests an interaction, which means that in this case, group 1 will have factor 1 and factor 2 variations. Group 2 will have factor 1 and factor 2 variations. And group 3 will also have factor 1 and factor 2 variations. This means that this time I will have 3, 1, 2, 3 times 2, 1, 2, 6 groups, and the control group. I've taken a control group separately here because control group participants will not see any of these interventions, and none of them varied with these levels, right? So that means we have 3 times 2, 6 groups plus 7th group is our control group. So this is an example of a more complex factorial design, where this time we're looking at the interaction between 2 factors, 2 independent variables in our experiment. How can we write it up? Obviously, it's a more complex design. Very easy. We follow exactly same logic. But this time what I've done, I've taken a control group out of the overall bracket. What I'm saying that it was a 3, and then in brackets I have the names of the first 3 interventions times 2, and now I have the names of these 2 factors and the name of this overall independent variable. And it is a 3 by 2 factorial design, and it's again between subjects design. Do not get confused by these 2 and 3. It's not 3 factorial, doesn't mean there's 3 factors. Your factor is here in brackets, and these 3 means the variations within this factor. That's what it stands for. And it's a 2 factorial because this is your first factor and you've described it, and it's times your second factor, and this is where you describe it. So numbers here do not mean the number of independent variables. It's the levels of variations inside your independent variable, inside your factor. Just to highlight once again, when there is an X sign between the first factor and the second, it means that all of these levels will be interacting with these levels, because my control group does not have any of these manipulations and their interactions. I've taken it outside the brackets. So this time I have 3 times 2, 6 groups plus a control group makes it 7 groups. You may be super confused now, so let me show you an example. I will start gently and slowly with 1 factorial experiment. This is a fictitious hypothetical experiment. I made it up for the purposes of this video. Let's say in this experiment we are trying to investigate which of the packaging labels will result in consumers purchasing products with cute stickers. And based on knowledge in psychology, we are hypothesizing that people will purchase products with cute stickers if we prime them with cuteness. One of the ways for us to do it is to use Kinder schema, in other words, to show pictures of babies to consumers. In the first condition, we will expose consumers to pictures of children. And our second manipulation is a control group which does not have this intervention. They will see the picture of pens or pencils. And our hypothesis here is that exposure to kinder schema to pictures of babies will result in a greater number of products selected or purchased with cute stickers compared to the control group. In this case, we have a one factorial design. One factor is actually kinder schema manipulation, yes or no, and this is how we would write it up. We have a two kinder schema present versus absent, which is our control group, factorial between subjects design. Between subject design also suggests that individuals were randomly allocated to one of these two manipulations. Now let's say we ran this experiment and we've proven that kinder schema does indeed impact on a greater number of products purchased or selected with cute stickers on them compared to when people are not exposed to such priming condition. Let's say we want to investigate this phenomenon a bit further and say, okay, would we observe exactly the same results if we have positive or negative peer comments? Let's say we expose people to kinder schema, so naturally they should purchase more products with cute stickers on them. But if we expose them to a condition where their peer makes a negative comment saying, oh, wow, this is too childish, that will not result in higher selection of products with cute stickers. And that should be different to the condition when the peer appraisal is positive. The peer would go and say, oh, look, it's so cute, right? So here we are saying that the effects of kinder schema will vary depending on whether there is a positive or negative commentary by a peer accompanying them to the shop. So in this case, in this study too, we are looking at our first independent variable, which was kinder schema present or absent, but we're also combining with peer influence, which is very big in social sciences and social psychology and also marketing. Peer influence on purchases is an established big factor. So now we want to see what is going to happen with kinder schema impact if different peer commentary is present. And this is what is captured by this X, which is the interaction between two factors that we are studying. And here we have one group, which is kinder schema, that will be varied in terms of peer commentary. One will be positive, another one will be negative. And we also have a control group. So we have three groups overall. And this time, because it's our second study, it means that our hypothesis needs to account for it. Our first hypothesis stayed exactly the same. Kinder schema manipulation should result in a greater number of products purchased that have cute stickers on them. But this time we introduce hypothesis 2, which actually accounts for this interaction. And we are saying kinder schema manipulation should create a greater number of products purchased with cute stickers on them only when positive peer comments are present compared to when negative are present. How to write it up because it is more complex? Again, we follow the same conventional rules. This is how we would describe this experiment. This is my first factor. This is my second factor, and it's between subjects design. First, I have one kinder schema present condition interacting with peer commentary, positive versus negative, factorial between subject design with a control group. I've taken the control group out because it does not have any interaction with positive or negative peer commentary, nor there is no variation to kinder schema. There, of course, could be more complex experiments which would require a lot of thought in terms of theory and preparation, where you may be looking at a three factorial experiment. And this is how it may look like, but keep in mind this is way getting more complex. So you need to have a really strong theory, and it's harder to develop the hypothesis, and it's harder to do the empirical analysis. The harder sometimes doesn't mean the better. The experiments sometimes need to be simple and quite crisp to establish the main effects. But just to show you how to describe a three factorial between subject experiment, I have this example for you on the screen. It is a three first independent variable name for group 1 versus group 2 versus group 3 times the second independent variable and its name for factor 1 versus factor 2, interacting with its third independent variable and its name, and then you list the factors, and then you say it was a factorial between subject experiment with the control group. I've taken control group out because it does not have any of the variations from the first variable, from the second, and the third. It is by far a more complex design, both conceptually and empirically. Let's have a look now at within subjects design and how to write it up. Because in the within subjects design, our participants are exposed to several treatments, or they view all the advertisements, or they are exposed to all of the manipulations that you have, we write it up in a slightly different way. And usually we would say that it was a one factorial within subject design. And one here says that even though we had advertisement 1 and advertisement 2, the participants saw all of them. This is what this one stands for. They saw all of them, advertisement 1 compared to advertisement 2, but they saw all of them at the same time. And this time we are saying that it was within subjects design. Within subjects design, the mere usage of this word already would suggest to a person who reads it that a person saw several interventions, several manipulations at the same time. You can also say that it was a one factor, this factor, within subject experiment, or it was a single factor within subject experiment. If you, for example, had a control group, then I would just say it was one factorial within subject experiment with a control group. Because in this case, it's outside the brackets because they did not see advertisement 1 and advertisement 2. If you are having a more complex experimental design where you have within subjects design, but you have group 1 which saw advertisement 1 and 2, and you have group 2 which saw advertisement 3 and 4, or you vary the order of the first and second advertisement here. So it's advertisement 2 and advertisement 1, and you're trying to see whether that is more effective than this combination. Then in this case, 2 here will actually say that one of the groups saw only one of these combinations. One group saw advertisement 1 versus advertisement 2, and the second group saw advertisement 3 versus advertisement 4. And again, it's within subjects experimental design. One last note before I finish, and it is about moderators. Moderators do not form part of your factorial design. This is very important to keep in mind. I have a separate video on the role of moderators and what they are in experimental research, and I encourage you to watch it if you're not familiar with this terminology. But for the purposes of this video, I would say moderator is usually an individual consumer difference, something which varies between consumers, and that impacts on the strengths of the relationship between your intervention dependent variable. In other words, you may be exposing consumers to a lot of different ads or to specific ads, but not all of them will react or respond to them in the same way because there could be individual consumer differences. Someone may not pay attention. Someone may not like the color. Someone may not like the music. And that them liking or not liking them will be a moderator. Here, a logical moderator to have is individual preference for cuteness, how someone likes or dislikes cuteness, and that will impact on top of these intervention manipulations, on top of positive or negative peer commentary, that will also impact on how they react to your advertisement. But the moderator does not form part of your factorial design. This is something that usually forms part of your conceptual framework. You collect this measure during the experiment after you exposed people to your intervention, and then you model it statistically because it allows you to account for more variations in data and hopefully establish the phenomena that you are studying from a more well-rounded examination perspective. What's also important to keep in mind that you would have to have a hypothesis for your moderator. So what I'm saying here is that those who have higher preference for cuteness will experience greater positive emotions than those with low preference for cuteness. So they will not be affected by any peer commentary. It actually doesn't matter which peer commentary is present. Now, you may come up with a different hypothesis if you'd like. You can leave your comments down below if you want from me. And my second sub-hypothesis could be for those with lower preference for cuteness. And here I'm saying those with low preference for cuteness will experience greater positive emotion when a peer makes a positive comment versus negative comment. So for those who do not like cuteness, they will experience greater effect or they will purchase more products only when it is accompanied by a positive commentary because they actually don't like it, but then there is some peer pressure. Okay, I'm going to buy this product, right? But when there is a negative commentary and you do not like cute things, that will have a very off-putting effect on you and you're not going to purchase this product. I've split moderator hypothesis into A and B because as you can see, it's more complex. I have low versus high preference for cuteness. And when your moderator is very complex to explain, it's better to break it into separate subheadings. Now, this is everything for the factorial design and how you describe the complexity or simplicity of the experiment that you have carried out. I hope you enjoyed this video and I hope you learned something new today.